Yeah. So, welcome all to this week 12 live question answering discussion session. So, this is an last session about the question discussion session of social network course. Yeah. So, we'll discuss the questions in this session, which is related to the myopic search and the comparison between the optimal search and the myopic search. How much? One second. How much time it requires and uh, means how what is the shortest path we'll choose by myopic search and the optimal search, right? Also, we'll discuss the questions related to the we have seen in the cascade or that infection cascade infection. So in that, the most important part is the cascade information spread. In that, most important part is an key nodes. The key nodes represents that those nodes which are uh, which are mostly influential nodes. Means whatever the suppose the information consumed by those users, the key nodes, then there is a possibility or then the cascade of information will spread across the network, right? So the infected users is higher when the key nodes is very high influential, right? So related those, we'll discuss the questions, and along with these questions, we'll also brush up some concepts related to particular questions, right? Okay, let's jump to the questions. So in first question, which is a very simple, it asks about the general thing. Which of the following statement is true for internet memes, right? So anyone want to say something? So internet memes, let's see the options one by one. So along with that options, we'll understand what exactly the internet memes is, right? So the first option says that the internet memes are exclusively images and never involve the text-based content. So it's not exactly the what statement one is stated that is, and it's not about the what the content is. It is about the how the information is spread, to which any content which spread more across the network, that that information we are calling as an internet memes, right? And that information may be in any format, which is an image, audio, video, or any other formats as well, right? So let's see the whatever I said, which option match with that particular statement or not. The in second section option, the virality of meme is independent of its reliability and cultural relevance. It's not exactly the reliability and cultural relevance. It's somehow it's related, but it's not exactly what the meme is, right? The third option states that memes often spread through social networks, be it in with an image, audio, video, or file in some other format, right? So this statement, what I stated, which is an more similar with this third statement. Let's see what fourth statement states that memes have a consistent and universal interpretation across diverse cultural background. One second. Memes have a consistent and universal interpretation. It's not exactly consistent or universal interpretations has been defined to a meme actually. It is an diverse information. It may be related to any political information, may be related to any religious. Right? It's not defined to a consistent factor or consistent cultural background. Right? So the option three, which is incorrect, which states that what is an internet memes exactly, which the internet memes which actually often spread through social network, and it is in any format, which is an image, audio, video, or any other format as well, right? So that mostly important is it is spread across the social network, and it may any format. So the here option 3 is correct. Okay. So I repeat, is there any doubts? Please let me know at that point of time, so we can discuss thoroughly that particular queries. Okay. Yeah. So let's move to the another question. The questions two states that what is or are the factors responsible for a meme to go viral? Right? So which are the factors we have stated in the maybe in while we have started the discussion in lectures, which is in pseudo course. In the introduction of the pseudo course, we have discussed which most important factors are responsible for to go meme viral, right? So in this the meme how, so let's relate with the current scenario. In current scenario in Instagram, let's assume that as an Instagram one example, and in that we have seen there is a lot of influencers are there. So their content is not directly viral in a one day, right? So they have made a quality video, and they have connection with their best friend, and that circulate in friends of friends that content, right? So like this way the content, one content is go viral, another content has also the same quality, and the network is so well densely connected in that also that content particularly goes viral, right? Yeah. So let's see the options here. The options first states that only quality of the meme. It's not depend only on the quality of the work. It's also depend on how the friends are connected to each other. Right. Suppose that user one has created a post, has created a one meme. Okay, and he's posted on the social media, and he has only one friend. Okay, so in that case, that particular information, that particular any video or meme is not spread across the network, right? Because only that particular user has only one user, one friend, and there is a no further connections are there, right? So the no information has propagated or spread across the further network, right? So here the quality of the meme may be good, or maybe it's very nice, but the connections are not there. Connection are required, right, to spread the network, spread the information. So here only quality it's not required, only structure of the network. Okay, suppose you have densely connected network, you have connected with the friends, which is an densely means you are strongly connected with the friends, and your friends of friends, their network is also strongly connected. Okay, so and the structure is here, it's very nicely connected, right? But you have posted posted a information, any video on Instagram, which is not that much good quality actually. There is a content is not that much quality, there is a no new in that particular video, and there is a no background music is interesting and like that way. Okay, only the video is there, and it's not that much quality is there, and that video is posted to a friend, or to your that particular user's connection. But that connections, that friends is not like that particular content, right? So that they have not propagated or spread that particular content forward, right? Suppose that the meme is very quality, or it is very interesting, and it is very relatable, or it has some novelty in that particular video, then the friends or friends of friends, they are taking interest to share this particular video to their further network or further friends of friends, right? As we can relate with our real world life, suppose is there any reel we have seen, and that is very relatable to any situation which is already happened with us, or which is related to our friend, close friend, then what we can do, we are sharing with our friend, right? So he is also watching that, and he's also someone to relate with someone, right? He's also sharing with them, right? Like this way the propagation has been happened, right? So only here the meme quality is not required. Along with the meme quality, it requires the structure of the network as well. How that structure of the network is densely connected, right? So the option 2 is not also correct. Option 3 is correct. You can see here the both quality of the meme and structure of the network. These two information, two parameters are important to go your information, go your video or any images or any post go viral, right, in the network. So the quality of the meme, quality of the your post, and the structure of the network. Okay. So here option 3 is correct. Okay, let's move to the another question. Uh, what happens during the ith iteration of k-shell decomposition algorithm? Okay. So here, okay, so anyone wants to answer this question? What exactly happened in ith iteration of k-shell decomposition? Okay, so to understand k-shell decomposition, needs to understand also the what is an k-core. Okay, so we have seen, so why we have studied the k-core actually. So the k-core we have studied because we need to find the key nodes from the network. Those key nodes represent the influential nodes. Okay, what is means by influential nodes? Suppose let's take as a social network. Let's take as an Instagram social network, and in that there are some nodes. They're not all of the nodes. There are some nodes, some users are influential. Influential means they are whatever they are posting or branding some company's product. The most of the peoples are influenced by their post. Right? Most of the people. So those are the influential nodes. I mean, so though they are infected most of the peoples of the network, like this way. So to find the from this oral network, from to find the key nodes, we have studied the k cores. So let's see what exactly the k cores, how we are finding the k cores. Okay, so let's take as an, okay, here. So let's take one network. Hmm. So the one core means that is the nodes which has uh, greater than one degree, greater than and equal to 1 degree. So overall, this graph represents an one core, right? Let's take as an let's find as an subgraph which has an core two core represents. Two core means that the nodes which has greater than 2 degree, greater than equal to 2 degrees. So let's see, this node is also greater than 2, this node, this node, this node, this node. So this subgraph represents a two core. Okay, the three core. Three core means the nodes which has greater than equal to 3 degree. Right. So here this code is not included. This one, this one, this one, this one, and this one. So these are the three core. Okay, like this way we are finding the cores, and we found that these three cores are mostly connected. Mostly matlab densely connected. If someone got the information, let's take as an, suppose this node got as an header, it will immediately propagate or transfer to this node and this node and this node, because they are densely connected. Okay, so that's why these are further going in the k course, means suppose there is a 4 5 6 course, then that means those nodes are densely connected. In 6 cores, as compared to the 3 core, the 6 cores users are densely connected. Whatever the information you can given to, or one node is infected by any information, then other nodes gets infected immediately. Okay, like this way. So these nodes, we are mostly, and mostly it is a we are also found in the lectures, they have discussed that, that is in this course, inner core, which are mostly represented as an influential users. Okay, so whatever the information they got, they passed in their densely connected nodes, and also it goes further also, that is in peripheral nodes. These are outsiders, are peripheral nodes are there, right? So it goes to those nodes as well. Okay, this information like this. Okay, yeah, this is an K core. So what is an K shell decomposition? So why the K shell decomposition has been means introduced? See, so we have a social network which has and millions of nodes are there. So to finding this 1 core, 2 core, 3 cores, it is very difficult. It is very difficult. It is very difficult in a large scale network. Okay. So in small scale network, we can directly say that okay, this node has an 3 degree. Okay, let's this node has an will say an 3 core, like this way. Okay, but in millions of node, it is difficult to figure it out. The each node and the subgraph, finding the subgraphs based on the K cores, right? So we have, means researchers have introduced, which is an K core decomposition. Okay, K shell decomposition. So in that, what it exactly happens? There is a network like this way. Firstly, we are creating a bucket. Okay, bucket one, and in this bucket, we are taking we are removing from this node, from this network, which is those nodes has an less than 1 degree. So this represents 1k 1k shell, suppose. Okay, 1k shell means one shell means that is k is equal to 1, and shell it represents as an we are deleting the nodes which has less than equal to 1 degree. Okay, so which nodes has an 1 degree, also from the less than 1 degree, also we are removed from the network, and we are added this network in this bucket. So we have, suppose this name is an 1, then one node is added here, then we have removed this node, right? After removing this edge is also we have removed from the network, then again we are checking which node has an 1 degree or less than 1 degree. If it is not, then we are moving to the another bucket, bucket 2, which represent a 2 shell. 2 shell represents that which nodes who has an less than equal to 2 degree. Okay, less than equal to 2 degree, those nodes, like this way, these nodes we are about two nodes added here and removed from the this network, removed from this network, and their associated edges as well. Okay, right. So like this way, we are creating a bucket, and like this way, we are removing uh, the nodes from the network. Okay, and the last represent means whatever the last k shell bucket we are getting, that represented as an most what we can say, mostly influential nodes, and or we can say mostly densely connected into nodes. Okay, right. So, yeah, I hope you guys understood. I have given overall idea of what exactly the how it works, the K shell decomposition. So it is removing the nodes and it is adding to the bucket. Based on which condition? Based on the K condition. K is equal to 1, then we are removing the nodes which has less than equal to 1 degree. Those nodes who has an less than equal to 1 degree, those nodes we are removing, and then we are adding to the bucket B1. Recursively we are removing. Recursively means what? Firstly we have removed this one node, right, and their associated wedge. Then we are also checking, is there any nodes has gets only 1 degree after removing the before node and edge. If it is there, then we are adding to the bucket 1. If it is not, then we are moving to the k is equal to 2. In the k is equal to 2, what we are doing, we are removing those nodes who has less than equal to 2 degree. Okay, like this way. uh, okay, I hope the overall idea you are getting what exactly the how exactly the k shell decomposition help algorithm will works. Okay, so based on this, we'll see which answer match with the our explanation. Okay, what happens during ith iteration of the k shell? Ith iteration means we are doing a this is an first iteration, right? This is a second iteration, third iteration, like this way. Okay, remove all nodes of I degree. We are removing id means we are removing, suppose there is an iteration 2, that is in 2 bucket. We are removing the nodes who has an degree 2, but also there is another condition that we have discussed. Let's see the other option has that particular another day, condition or not. So here only one condition is there, so it's not perfectly matched with our discussion about the k shell decomposition algorithm, right? So it is not correct. Remove all nodes of degree I recursively. Okay, it is correct. This is also not partially corrected, because we are not only suppose we have removed the 2 degree node and then we are going forward. It's not like that. We are removing the 2 degree nodes uh, recursively. Recursively means what? Firstly, we are removing the nodes which has a 2 degree. After removing their nodes and the associated their edges, then again we are checking, again we are validating, is there any other nodes are there which has an 2 degree after removing before nodes. Okay, like this way. So that recursively the word is important here, so that there is a no node with degree I anymore. Again, in this there is only one condition has been uh, checked or considered, which has an the degree, it is removed all the nodes which has an degree I only. But we have to also consider another condition. Let's see what exactly the other condition will be there. In third option, it states that remove all nodes of degree less than I, less than, okay, less than I recursively. So these two options has partially stated the conditions or working of the k-shell decomposition algorithm. It first second option states that it they have removed the nodes which has a degree I recursively, and second third option states that they have removed the nodes which has a degree less than. But we want combined, we want a 2 degree at a time, two condition at a time, so which has an degree equal to I and as well less than equal to I. Okay, degree. So let's this option is also not correct, this is also not correct. Okay, remove all nodes of degree less than or equal to, this word is important, less than or equal to I recursively, so that there is a no node with a degree less than or equal to anymore, less than equal to I anymore. So option 4 is correct here. Okay, so till now is there any doubts or any queries? If it is a silly doubt, please let me know in that case as well. Okay, okay, let's move to the another question. Yeah, so which of the following statement is or true? So the statement one states that core nodes of a network are removed in the last iteration of the K-shell decomposition algorithm. What do you think? Is it correct? The statement 2 states that periphery nodes of a network are removed in the first iteration of the K-shell decomposition algorithm. As we have discussed that, K shell means one shell, that k is equal to 2, and suppose at max, let's take as an max possible shell. Max possible means the node which has a max number of degree, right? So firstly understand what exactly the periphery nodes and the core nodes are there. So as we have seen that, let's take this example. Okay, let's take this simple example. So this is so this inner part represents as a core. Why we are calling as an core? See, suppose the one node is infected or has get some information, then it is immediately pass on to this node and this node, these nodes, because they are directly connected or densely connected to each other. Right? So that's why we are calling as in these are the core. And after circulating, after passing this information in between these nodes, which are in densely connected, then it is easily passed to these nodes as well. Okay, these are passed to these nodes as well. So these are mostly densely connected nodes, which are the core of the network. Okay, the information has infected to these nodes, then there is more chances to get information spread across the network. Okay. So this is an core representation. This is for this we are calling as an core. Okay. And these are the periphery. These nodes are the periphery nodes. Okay, these are the beside of the core nodes. Right. So these nodes, observe here, these periphery nodes we are removing from the network at the first iteration, when the k is equal to 1, k is k shell, that is k is equal to 1 means one shell. That means we are removing the nodes who has uh, degree less than equal to 1. So here you can see these nodes are degree 1, degree 1, degree 1, degree 1. So these nodes are we are removing at the first iteration of the node. After removing, you can see here which nodes can be removed. Recursive, right? So this node has an 3 degree after removing as well, the 3 degree, 3 degree, 3 degree. So the k first is has been done, first core is there, but two core there is no subgraph as such there. Or two core there is this represented in two core, because what is the definition of the two core? That is an the degree greater than means greater than equal to 2. That means that subgraph represents an two core representation. Okay. So here 3 represents that 3 means in the third shell, that k is equal to 3, we are removing these 3 nodes, 3 degree nodes. There is a no further buckets can be created or introduced, because there is a no as such nodes are left in the network. Okay, so that's why this last bucket represents as an core of the nodes. Are you getting? This last bucket represents core of the node, and the first initial iteration represents bucket represents as an periphery of the node. So here the statements stated correctly, which is an periphery nodes removed in the first iteration, and the core nodes removed the last iteration. So the both the options are correct here. Okay. I hope you guys understood. Let's move to the another question. Identify the node that has spreading capacity similar to the innermost core node, but does not belong to the innermost core. First understand what exactly the innermost core is there. Right? So by okay, so let's take this example. Okay, like this way the network is there. Hmm. So as we have stated that these are the cores, and this outer side is represented as an um, periphery of the network. So as we have found that means we are crowding the or removing nodes or in the K shell, in the perspective of the K shell, what we are doing, we are removing the first periphery node. After that, some 2-degree nodes, less than 2-degree nodes, less than 3 degree, less than 4, less than 5, like this way we are doing. So the reason, firstly, we are removing the last, the mostly the last uh, deleted or removed node which are densely connected, which are the core of the nodes. The second latch which represents, which is less than influential power than this core. Let's assume, suppose we have extracted or we have created the buckets up to 4 core, the 4 core shape, right? Like this way. That 4 represents as an mostly influential nodes. Okay, and third one, little bit lesser influential nodes. Let's call this as of now to understand easily. Okay, and two core nodes represents that is an less than the 3 core nodes influential power. Like this way, this influential power decreases over the k cores. So I can write here. So this is an 1 core, 2 core, 3 core, 4 core, right? And this core has an highest influential power that we are assumed right now. Okay. So this represents also as an innermost core, innermost core that we are calling. So this represents what has been mentioned in the question, which has an identify the nodes that has a spreading capacity similar to the innermost core nodes, but does not belong to innermost core. So you can see these nodes are innermost. So we need to find out which are those nodes which has a similar capacity to spread the information like innermost cores, but they are not belonging to the innermost. So those are maybe from this part of the network, right? This part of the code, this part, this part, right? But you can see here, these periphery nodes has not that much spreading capacity as compared to the innermost, right? So this much is also not compared, but you can see this innermost and their alongside or less than 1 core k core, that is in this mode, this has some capacity to spread uh, information as similar to the innermost. Also, it is scientifically proved that, which is an means what we have assumed, that is, and suppose the k core increases, influential factors is also improving. Means suppose higher the k core, that is, and higher the influential power, that we have assumed right now, right? But it is not actually like that. It is scientifically proved that there is an experiment has been conducted, which is an about the influential power and the k cores. K cores means here 1, 2, 3, 4, 5, like this way. So at initial k is equal to 1, there is influential power is very low. That is in peripheral nodes. They are they have not that much influencing capability, right? So the it goes like this way. Sorry, it goes like this way, and after certain point of time, it has a stable. Okay, it is not going increasingly. So it is unstable. So that researchers has found that not every time, not most of the time, the inner core has an capacity is greater than their previous one. It's not like that inner core has every time has an the influential power is higher, right? You can see less this, suppose this last one is an inner core, represents an inner core means highest core value. K is equal to the highest value which has which those nodes are presented in the network, right? Higher core. Less than this, it's an also the less core value, but you can see the capacity of the influential power which is an similar compared to this. So as in the lectures they have taken one example, which is, and suppose you have one company which is a startup company, and you wanted to make a by uh, promotion by hiring the influencing nodes. Suppose let's take as a in Instagram social network platform, and in that there is a huge influential nodes are there. Like that means example. Let's take as an example which is an Amitabh Bachchan's a user, right, and Shah Rukh Khan's user, right. Another is an Salman Khan's. Or these are the film stars. I am taking the names for the simplicity. There are must uh, domain wise influential nodes are there. Okay, so right. So we are approaching as a startup. We are approaching to them that particular influential. Those represents. Let's assume that right now those nodes, those users represents as an uh, the inner core of the network. Okay, in India, let's take an example. And but we as a startup we can't afford that to hire those influential users, right? As a startup, so it's not to take to give to bring our product to them and to say them please do the promotion of this product. It's, and they are hiring too much of the cost, and that is not bearable to a startup like team, right? So we have to hire less core values, less core influential users, right? So right now, and less core, we have to choose the nodes which has similar, most of the similar capacity to spread the information, spread the promotion. Suppose if you hire the Shah Rukh Khan, let's assume that okay, and 50 nodes, 50 users are influenced. Let's assume that for the simplicity. And also you have hired another person which is not from the inner code, that is Shah Rukh Khan is from the inner code, and let's take a one influencer node, influencer user, which is just now has famous from his Instagram or real content, right? And you have hired them, which is of course it is less cost to be paid for this influencer node as compared to the Shah Rukh Khan, right? And he's not belonging to exactly the inner core of the network, right? Let's assume that, because he has an not that much dense connected as compared to the Shah Rukh Khan, right? Like this, it is a little less. He has an dense connected, but little less dense connection than the Shah Rukh Khan, right? But the spreading capacity of this particular influencer user has a similar. He is also influencing the 50 nodes, 50 users, right? The Shah Rukh Khan has also spread the 15. So the most of the what we can say, the startup companies, they can approach to that particular uh, influencing users in a minimum cost, right? So this has been found in the literature, and that's why we are calling those influencer nodes as not as an inner core, or not exactly the core of the core nodes of the network. We are calling those nodes as an pseudo core, right? Those nodes who has similar capacity, with the similar capacity to the innermost core nodes, but they are not belonging to the innermost core. So for those nodes are the pseudo core. Those node are belongs to the pseudo core, right? I hope you guys understood. Yeah. So this is very simple. Is anyone wants to answer this question? Is anyone? Okay. Okay. A subgraph of a graph. Okay, subgraph of a graph is known as four core. If what exactly it means? Subgraph of a graph. Okay, subgraph means there is one graph. Okay, and how we are core defining in the k core, how we are extracting the subgraph which has satisfied that particular k core condition. Suppose the k is equal to 2, we have to extract, we have to capture the subgraph which has every node greater than equal to 2 degree node degree, like this way. Suppose the k is equal to 3, that means 3 core, which represents we have to consider or capture the subgraph which has every node which has degree greater than equal to 3, like this way. So this is how, suppose let's take this one. So we have to find from this network uh, 4 core 4 core subgraph, right? So this whole graph is not in 4 core, right? You can see here node as in present in 2 degree. So the k 4 core k core definition is that define that every node from the graph, consider the graph, the degree is greater than equal to the k. The k here is an 4. So which nodes are represented in k core? This one and this one. You can see this node has an 4, this node has an 4. So these two nodes has been considered, which is an 4 core. That is, suppose A and B. So A and B subgraph represents an 4. So I have already mentioned the answer of this question. So you can go here or you can see here. Each node has a maximum degree along with the maximum degree, not maximum. Each node has a degree strictly less than that we are checking in or validating in k shell, right? Less than equal to k or not. Each node has this, only less than it has been mentioned. There is a less than equal to as well, is there condition the k shell. Each node has a degree equal to 4, third option. Equal to, it's partially corrected, it's not exactly corrected. Fourth option, each node has a degree greater than or equal to 4. Greater than and equal to, that is important. So it is in greater than equal to 4, that subgraph represent. Then it is K core. So the option 4 is correct. Yeah. Is there any doubt? Okay. So in yeah. So this is a true false question. In statement one, it states that myopic search always performs good as an optimal search algorithm. Is it correct? What do you think that? Is it correct? Myopic search always performs good and optimal search. Okay, let's see what exactly stating. Statement 2, time taken for myopic search increases logarithmically with an, is it? Okay, the first statement, let's validate that, or let's see what is and how the myopic search performs good or not with the comparison of optimal search. Let's take as a one-dimensional structure which obeys the homophily properties and the weak ties properties, as we have seen for drawing or for creating a small word network. We need to uh, consider two hypotheses, two properties, which is an the network should be an homophily and should be able to obey the homophily property and the weak ties, which has a weak ties. So considering this, okay, this one, and let's take so let's take another node here, and suppose we want to find the shortest path from this source node to this target node. So let's first how the myopic search algorithm works. Let's see that. So it is okay. So it is wiring has been done. So here you can see it is connected to the geographically nearly nodes, which is an homophily represents an homophily, and it is connected remote locations as well. Remote means that is an far away from the nodes, right? That is an wiring has been conducted, has been drawn here. So which represents small word network. Okay. So considering this, how the uh, optimal or myopic search always performs. Let's see that. So the first it goes to the source node. We'll take a color, another red color. The source node, then source node, then it searches his neighboring nodes. Which are the neighboring nodes? This one, and this one. From this neighboring node, what is the distance to the target node? You can see from this node 1 2, the two edges are there, two distance are there. From this node there is an 1 2 3, three distance are there. Sorry, what I have it, three distance from this node 1 2 1 2, sorry. Suppose he chooses this neighboring node, it has an three distance. Let's see, 1 2 3, right? Suppose he had choose this path, then 1 2 3 4, four distance is there here. If he has chosen this path, then there is a 1 2 3, three distance is there, right? Like this way. And suppose let's take another each from this support. Okay, three nodes are there. Myopic search only it is saying in my neighbors, uh, where are my the neighbors, from which neighbors I'm getting faster to the target nodes. It is not watching neighbors optimal path. And suppose he has reached to this node, then his one step he can reach to this particular uh, particular target node, right? In a two step, right? If he has choose this path, then it will be reached into two path. But in myopic search, it's not happen like exactly like this way. It is choosing from this neighboring node. Okay, this neighboring node, which path it is getting shorter, it is 3 4 3. So from the 3 it is randomly picking this any node actually, right? So it is picked this path and he will reach to this 3. In optimal search, what exactly happening? Optimal search, I will take as another which color should I take? In optimal search, what exactly it is checking? It is going to this node, so it has a minimum in two distance it will reach to the this node. In my big search it takes three distance. So this first statement is wrong, it's not correct. Myopic search always performs good as an optimal search is not like that. Okay, okay. Optimal search, I have already mentioned that how optimal search is in, better in some cases. In statement 2, time taken for myopic search increases logarithmically. Yeah, it's correct. We have seen that how the time is increases like this way in that comparison we have conducted. There is a number of nodes are there. In that number of nodes, there is average uh, shortest path we have shown here. That means how much distance, how much hops needs to uh, for pass on to reach the target node, that we have seen. And we have seen there is an increasingly linearly increasingly by logarithmic with n, right? So here the option 2 is correct only, not option 1. Okay. So in this question 8, which is there are two more questions are there only. Okay. Identify the core which has the most influential people in the network. So they have given a k values here 2, 3, 4, 5. So we have to choose which core value which is an higher most influential people in the network. So what do you think? Which value should be is an mostly influential people in that particular core? What do you think that? It's very easy. One second. Yeah. Anyone? Sorry. This. Mhm. Is anyone? So as we have stated that here the maximum k value is an 5. That means in the network there is an nodes are present which has an 5 degree are there. From the network there is a one subgraph. In that subgraph every node has an 5 degree. 5 degree means 5 other nodes they have connected. That means those nodes are innermost core of the network, which has an which represents a core of the network, and which has the highest or we can say higher influential power, which can uh, influence most of the people from the network. So here the 5 value is correct, which is as I already stated that what one core represents, what two core represents, what the maximum core value represents. I have already stated that. Okay. Yeah. Yeah, let's move to another question. Which of the following is true for decentralized research? So let's see what the options are stated here. Only one primary node performs the search. Right? Node, primary node is not like that in the primary. That is a myopic search we have seen that they are asking. Myopic search is related to the decentralized search, right? The effort is shared across multiple nodes. Yeah, that is true. The effort is shared across multiple nodes. It's not as in just two nodes, just one node. It's not like that. All nodes are involved in the search event. Already mentioned the example here. Not all the nodes are involved in the search path actually. Right. So this is not correct. The effort is only two nodes. On only two nodes, the primary and secondary. It's not also correct. It's not about the only two nodes has been involved in the that search operation, searching the decentralized. It is involved multiple nodes to choose the multiple nodes. Why? Because in the shortest path there can be a single path will be there also, but there may be a shortest path which include greater than two nodes as well, right? Yeah. So let's see the last question. So in this question, let's see what exactly it is asking. On a connected graph G, connected simple graph. Okay, this is a simple graph. We can measure the distance between two distinct vertices Vi and Vj as the number of edges on the shortest path between them. They are stating that up to this. I will explain what exactly they are saying. They have consider a graph which is a simple connected graph. Okay, it's not as in disconnected, right? So it is a simple connected graph, right? There is no disconnection is very. This is an disconnected graph, but it is they are saying it is an connected graph. Okay, like this way. And after that, they we can measure the distance between two distinct vertices. Let's take two distinct vertices, which are these this one and this one. So what is the distance? How the distance we are calculating? Shortest distance in between the. So we are measuring how much edges involved to reach to this particular node. This is source and this is target. Let's assume that. Okay. So let's see the which this one, then this one, the three, one, two, three, one, two, the three. uh, the distance between the this source and target is n 3, which represents as a number, which is this is number of edges we have considered, but which represents shortest path between this yes, source and target user. Okay, yeah. So let's read another means further question. The diameter of a graph G is the maximum distance between any two distinct vertices in G. So they are saying there are multiple shortest paths are possible in the pair of the nodes, right, from the network. They are stating that choose a shortest path which is an maximum distance, which has an uh, maximum distance overall the all pairs of the shortest path. Okay, and that maximum shortest path represents the diameter of the graph G. You're getting, yeah. What is the diameter of complete graph having n vertices? So the now question they have asked, you have a graph which is an complete graph. Complete graph means what? Each node is connected to every node. Right? Let's see this one. So this node is connected to this node is connected to this node, like this way. It's connected to this. This node is connected to this. Connected to this. I hope all the connections has been, all the nodes are connected here, right? So these nodes are remaining. So this is a complete graph. Every node, each node is connected to every node, right? So considering this, what is the diameter of this graph? It's very simple. Anyone want to answer this question? What is the diameter of this network? Diameter states that the maximum shortest path from any two nodes. What is the possible maximum shortest path here? You can take any node. Let's take this node, and this node. What is the maximum path? Is anyone? What is the maximum path? Suppose let's take this one, this to this one, this to this one. Any node to any node. What is the maximum path? So here you can see the maximum prop on this node to this node is an only one node, 1 degree, one edge is there. So one is there. Here you can see only 1 degree is possible. Only one edge is you can possibly we can in any node you can reach to any node in one edge only. So here the option is one is correct. Option two is correct. Answer is one, right? Yeah, I hope you guys understood the last part of this course, social network. That is a myopic search, decentralized search we have seen, and we have also seen the K core K shell for to find the K key nodes, which are mostly influential nodes. Okay, I hope you guys understood. Thank you. Yeah.